Welcome back to Armchair Architects as part of the Azure Enablement show. So we've been talking a lot about data this season. This time, the question that comes up is, how do you get any sort of meaning from your data? So let's go talk to the architects about that. Hey, well, welcome back to another episode of Armchair Architects in part of the Azure Enablement show. And now we're moving into a topic that we have heard loud and clear that people want us to talk about, which is data. And I wanted to start off at sort of like a data 101 level and ask a very basic question and take it at whatever level you want. But I would really like to understand the question, like, I am swimming in data. You can't see it, but there's some over there, and there's some over there. There's around here on my floor. I don't know how to make meaning of this stuff, right? Like this is actually the canonical problem, right? I got so much data, I don't know how to make meaning out of it. Can we go into that direction? How do you think about this question of making meaning from your data? How do you pronounce it? Is the question.
Well, I think that this is actually near and dear to my heart because this is something I'm doing right now for multiple teams here. And this is also probably related to our session on dark data, which is I know I'm capturing data, but how do I find it, use it, and actually synthesize it to answer my questions? And I think this talk is a little bit different than that one because let's assume that you don't have a data swamp anymore. Let's assume that you have a relatively streamlined way of extracting data from hundreds of thousands of transactions or mysterious funny messages coming from little devices that you've connected into a cloud provider. What is usually lost is context, which is how do I actually understand this time series message that I got from this funny little device which is only identified by a GUID in the IoT scenario or in the IoT space? How do I know where this thing was, who manufactured it, when its last firmware update was, what it's making, and then where it actually sits in physical space? All of those things are inherently absent from the little message that it sends into the cloud, which eventually finds its way into your data lake. And in order to answer questions, which many of our customers want to have answered, which is what's happening right now, how efficient am I, what's going to happen, and what should I do about it? Context associated with data, which is commonly, in my estimation, referred to as semantics, which is the meaning that data holds, and the context associated with it is super important.
Uli, it looks like you're about to say something.
Meaning and contextualization is obviously very important. But then think about the other piece that's often the case. If you look at data models, oftentimes the data designers don't really specify what they meant. Is this pounds in pressure, pressure in pounds, or is this in kilowatts, or whatever the measurement unit, for example, is often omitted because people know, hey, that's how we count. And that's really another element of this contextualization that often gets overlooked because people know, quote unquote. And I'm sure you remember the famous NASA event where one guy thought they were working in metric, the other one thought in imperial. Not a good thing. That led to a loss of a fairly expensive satellite or rocket or whatever it was. And so I think it's really important to think about all the aspects that Eric talked about, but then also bring something very simple. Hey, what is the unit of measurements we are using here? As one example.
So that's an example of sort of definition being important to context, if I'm understanding you right, and sort of explanation. I get the sense from our previous conversations that in addition to that, context also includes relationships, right? Because it's really cool that you get that one thing going boop, 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 every whatever boop, boop length of time is. But that's, if you're talking about, I don't know, a factory, a chemical factory, the thing that's going boop, boop, boop next to the thing that's going boop, 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 or beep, boop, boop. I don't really know what they're doing. I don't really do a lot of work in IoT. I'm assuming that's the noise they make. Also matters, right? And there is a relationship between those, ahead of you, behind you, in front of you, that sort of stuff.
Yeah.
So how do we think about relationships when it comes to meaning and data and context? Like how do we
think about it?
How do we describe them? How do we think about them?
I think about it in three ways. There's entities, attributes, and relationships between the entities. Those are things in which, from an architecture perspective, from a data modeling perspective, that's your foundation. So there's got to be a way, a technology or a model in which you can express those things. And the way that you do that is you use languages like RDF or a label property graph or any of these modeling languages to say, this is what my world looks like. These are the things that I care about. Some of these things actually correlate to physical objects, like in a traditional digital twins use case. Some of them might be business objects like work orders or supply contracts or things of that nature. All of them have exist as entities, which have attributes, which are properties. Those properties have meaning, like in Uli's example, units of measurement. And then there's relationships between them. And that's the way in which we want to present as architects and solution builders. We want to present that to our customers and our end users. Not necessarily this table has an associative entity which links to this table, and these are the primary keys and foreign keys associated with it. And I don't know the temperature measurement metric or unit of measure. We want to be able to say, hey, here's an experience that says these are the entities and attributes and relationships that you as business users or regular users understand. And if you're not sure what something is, you can mouse over it and get semantic meaning. This is the unit of measure for this temperature. And then that actually brings together context and contextualization. But in order to get there, you have to be able to tie these sets of data together. You kind of have to, as Uli says, conduct data fusion between multiple data sources in order to achieve this.
Well, this is a question I have for Uli. Uli, I would guess that all relationships are not always known a priori ahead of time, right? And to a certain extent, to get meaning out of your data, sometimes you're constructing relationships after the fact or in process. How do you think about that, right? There's the things you already knew that was connected, but how do we think about the things that we didn't know or that we're discovering or that we're working over our data to find? How do those relationships work?
Well, again, there are two models for how you think about this. The first one is a temporal alignment, right? Where the time measure is the key relationship edge, to use the graph language that Eric is always so fond of. Graphs are one way of describing things. There are other ways to describe things. And I'll give you a very concrete example. I'm sure all of you have seen the Boston Dynamics Spot robot, the little doggy-like thing. And that thing actually has the ability to host multiple sensor packs, but only one at a time. So you effectively, let's say you have 3 sensor packs, one for vision, one for audio, whatever. And you put one on there, it runs around, does its thing, and then an hour later it picks up another sensor pack. How do you model that? And how do you make sure that you understand that in hour 1, I use the vision pack, in hour 2, I use the whatever motion pack or whatever, and that you can actually reason over that? Because the dog, the robot is always the same, but the sensor pack, they're always the same, but the combination is actually the interesting one. And so this is not a discovery one. This is something that you schedule and you set up, but you have to now reflect it in your system. And your system has to be able to say, oh, I want to know what the robot actually was carrying at hour X of day Y and so forth, because your data analytics will be skewed differently if you don't really understand that. And obviously there's the pattern, the way the robot is walking. You need to understand locality, location, those kind of things. And then other things that come from outside data. So humidity plays a very big role in manufacturing, for example, especially when you do process flow stuff. It really impacts what's going on, or the weather in terms of, is it humid, is it hot, is it dry, is it cold? Those kind of things are really important. And so that's when you have to understand what is the data that you care about, what is the influencer, and then most likely you have to expand your view beyond just the raw data that you have to get to contextuality that actually really makes sense. And that's part of the discovery, is what really influences your data set. You have a data set that says the temperature inside, I don't know what thing, is this. Well, does it really matter? Is this now impacted by the surroundings because it's now minus whatever 15 degrees Celsius out there? Does that have an impact on how much you have to heat the pipe in order to keep the oil flowing or whatever? So all of these things are super important, and that's the quote unquote discovery from my perspective. And then you have to model it so that you can persist it and then bring it back when somebody asks a question. What happened to this pipe or this oil in that pipe at that time? You know exactly what the elements of data are that you need to bring back. And that's unfortunately experience and experimentation are the two pieces that I would put there.
So I know that Eric's about to say something. I just want to make sure I get both of your things, because you said there were two things associated with the question about relationships. One was a temporal proximity, and what was the other one?
It's effectively, let's call it causality. So where you have causal data, like temperature on the outside, humidity, and those kind of things, that you can't influence. They're very Zen-like. They just are, but they impact and influence what you measure and what the meaning of that measurement actually is, or the impact of that is.
Okay, cool. I just wanted to get that settled. Eric, what were you going to say about this?
Actually, the Uli's example made me think of something. And for many of our viewers that have been in the data warehousing space, this is not a new problem, right? So for those of my folks that are, data warehouse toolkit fans, Bill Inman or Ralph Kimball, depending on which side of the world you're on, we used to do this in the data warehousing days. We took a fact table, which is the raw data, sales data, let's say, and then we had dimensions around it. We had a salesperson dimension, we had a time dimension and product dimension, so we could figure out who sold what and when and in what quantity. Now, one of the challenges associated with this is what Uli's example made me think of is, David, let's say that you and I are working for the same company and I inherit your sales territory. Now, we have a history problem in which I can't actually historically take credit for all of your historical sales. If we make that change in the salesperson dimension, we have what we used to call, and probably still do call, a slowly changing type 2 problem. So what that means is, as much as you define the entities, relationships, and attributes that will help you contextualize raw transactional data, you actually have to make sure that you focus on how those models themselves will change over time, so that you're not actually looking back in history with today's understanding of how those entities, attributes, and relationships are implemented. So it's a very old problem that's kind of going to only be exacerbated by the different speeds, feeds, and data sources that we have in today's modern world.
I have to admit, I don't know what that sound is. But what that sound does remind me of is that I think what we're going to do is be heading, what it seems like the direction we're heading in with this conversation, which is a place I was hoping we're to go, is sort of a little bit now towards the implementation side of things. So if it's okay with you, let's cut off here and then come back and dig into some of the implementation sides of this data stuff that we've been talking about. Does that sound cool?
Sounds
Sure thing.
Great, and help whoever it is who's sneezing in the background is what I suggest.
It's not me.
Sean, are you going to live?
Thank you, folks, Eric and Uli and Sean, for joining us today on this episode of Armchair Architects as part of the Azure Enablement Show.